Hello there and welcome to week 8. This is going to be a huge week because we're going to start on trig. So let me just jump right to our summary. There's a number of things that you need to memorize this week. I'm not big on memorization, but there's certain things in math that you just can't do without. One, Pythagorean theorem. You've probably already memorized that. A squared plus b squared equals c squared. 2, the distance formula, the distance between 2 points, which is closely related to the Pythagorean theorem. And 3, this is video 3, is an overview on circles and circles in standard form. So this is the equation for a circle with center hk and radius r. Now the trick in section 5.0 is going to be to take a generic quadratic equation and rewrite it in standard form in order to get the center and the radius of your circle. For example, you might have x squared plus y squared plus 2x plus 2y equals 10. And you're going to have to complete the square in order to figure out the center and the radius. And the videos will walk you through that. Section 5.1 is pretty short. It's just an introduction to angles, how we measure angles, what an angle in standard position is, and a coterminal angle. So let me just mention coterminal here. In this picture here, I've got the angle negative pi over 4. Now, if you were solving, let's say, a trig equation, and you were asked to give your answer, give theta between 0 and 2 pi, then negative pi over 4 wouldn't work because it's not in that interval. So a coterminal angle with negative pi over 4 is 7 pi over 4. And so that's the answer you would give. Now, this section here is going to walk you through how to convert between degrees and radians. In calculus, we pretty much use radians all the time. And so you'll see in all my handouts, everything's in radians. I don't even do degrees. You don't have to memorize arc length or area of a sector formula. So let's see, moving on. This is the big section here, unit circle. If you haven't done any trig before, then you're going to have to invest some serious time here. Video 1 is just an introduction to the 6 trig functions. So if we're on a circle here of radius r, here's my angle theta. This is a picture right from one of the videos. Here's my angle. This subtends a line, and where this line intersects this circle is the point x comma y. And all the trig functions can be written in terms of x, y, and r. Sometimes they're written as opposite, adjacent, and hypotenuse. And sometimes we use x, y, and r. The nice thing about a unit circle, which is the handout that I have in this section that you need to memorize, a unit circle has radius 1. And so if this is y and this is x and this is the point x comma y, then sine is just the y coordinate and cosine of theta is just the x coordinate. And it simplifies things. And so let me show you that handout. This is a handout in this week's module, unit circle practice. First thing you want to be able to do is know your reference triangles. So there's a reference triangle for pi over 6, 30 degrees, pi over 3, 60 degrees, and pi over 4. The way I remember them is, first of all, the hypotenuse is always 1. For the pi over 6, this is the short side over here, and this is the long side, root 3 over 2. For pi over 3, it just flips. Long side's over here, and short side's down here. And then for pi over 4, both the opposite and adjacent sides are equal. And I tend not to rationalize, so I'll write 1 over root 2, 1 over root 2 for both. Of course, that's the same as root 2 over 2. Using those 3 triangles, you can literally fill in the whole unit circle. And so there's a key on the next page. You can see I've filled in all the angles around the circle and the coordinates corresponding to each angle. You have to be able to do that. And it's not as much memorization as you'd think. All right, so let me just walk you through some of that. For pi over 6, drop a perpendicular. Here's our reference angle. The opposite side is the short side. That's the y coordinate. The adjacent side, root 3 over 2, is the x coordinate. And that's the long side. For pi over 4, each side is equal. So this would be 1 over root 2, comma, 1 over root 2. For pi over 3, now the long side is the opposite side, and the short side is the adjacent side. The adjacent side is the x coordinate, so that's going to be a half. And then the y coordinate is root 3 over 2. And then we get up here on the y-axis, x is 0, y is 1. Now, these coordinates are just going to repeat using symmetry and plus minus. For example, if we bop over here, now drop a perpendicular, the x coordinate is negative. This is still the short side, so x is negative a half because we're in quadrant 2. And the y coordinate is the same as it is over here. It's root 3 over 2. You can go around the circle filling those all in, and then you'll know sine and cosine and tangent of all the angles on the unit circle. So you've got a lot to do this week, and that is the end of the summary.